Hi, I am Zhafran. So today me and my team are going to present about wireline formation test. So wireline formation test is taken with a wireline formation tester. So the wireline formation pressure is acquired by inserting a probe into the borehole wall and performing a mini drawdown and build up by withdrawing a small amount of formation fluid and then waiting for the pressure to build up to the formation pore pressure. This measurement can provide a formation pressure along the borehole, thereby giving a measurement of the pressure with the depth along the horizontal borehole. So the trend in formation pressure with depth provides a measure of formation fluid density, and a change in this trend may indicate a fluid contact. Unexpected changes in formation pressure measurement with depth indicates the differential pressure depletion and demonstrate barriers to vertical flow rate. Lateral variation in formation pressure measurement along the horizontal well in multiple vertical well can indicate heterogeneity in the reservoir.
Hello Madam Azad and fellow friends. My name is Ahmad and I will present about the operation of wireline formation test. Wireline formation tests such as drill stem test are run on either drill pipe or tubing. The tools required for this test consist of flow control valves, fluid sample chamber, inside pressure recorder, one or more packers to isolate the zone being tested, a perforated anchor, and temperature recorder. As the tools are run into the wellbore, the increasing hydrostatic pressure of the mud column is recorded by the pressure gauge. The tools are run into the hole with empty drill pipe or tubing. When the tools reach the depth of the formation to be tested, the packer is set against the walls of the hole or casing, thereby isolating the pressure of the mud column from the pressure in the test zone. Pressure is measured at the very bottom of the tool string and within the tool string itself. Then the flow valve is opened and the formation fluids flow into the drill pipe. As fluids fill the drill pipe, pressure obviously increases. After that, we close the control valve. This test is repeated for a few times for varying periods of time to estimate the permeability, the skin factor, and the storage coefficient, the wellbore storage coefficient. Thank you very much. That was all.
Hey guys, my name is Ayman and I explain to you about pressure measurement in wireline formation testing. So, after we operated the tool as explained by Tah earlier, we will get the pressure data. So there are two types of formation tester, which is single and dual pretest formation tester. The only difference is the amount of pretest before the build-up. So as you can see in the figure, this is a pressure recording by using dual pretest formation tester. It has two pretests before build-up. So using the pressure data that we got, we plot pressure and flow rate on the y-axis and time on the x-axis. When the tool is being set, the valve is open and the recorded pressure is the hydrostatic mud column pressure. Pretests are associated with drawdown. So as we can see in the figure, the pressure drop and stabilize during the first pretest and decrease further during the second pretest. When second pretest is completed, the well is totally shut in without any flow rate and the pressure build up to formation pressure. So actual formation pressure can be taken when the pressure becomes stable or can be estimated from the character of the build-up if it has not yet stabilized when the tool is retracted. So the next figure here is the single pretest formation tester. It is recorded just like a log. The left solid curve represents the pressure detected by the gauge within the tool sampling system. The hydrostatic mud column, drawdown and formation pressure is clearly detectable. So that's all from me, thank you.
Although formation tester can take samples, they are often run slowly for the pressure information available from the pretest. Figure 6 shows how such pretest data can be useful. In this figure, the well is shown penetrating a reservoir that has gas, oil, and water interval. The formation tester is set at a normous depth interval across this reservoir. The formation pressure recorded by the tool is indicated by an X, while the hydrostatic mud column pressure is indicated by an O. The degree of overbalance is clearly visible from the schematic. The fluid gradient are also dictatable, and the gas column is readily distinguished from the oil, which is also distinguished from the water. The location of the gas, oil, and water-oil contact can also be determined from the formation pressure profile. After a reservoir has been produced, some pressure decline can be expected. Formation testers are frequently run in development or in field well. When compared to initial reservoir pressure, pressure profiles in these wells often show that certain zone may have produced more than neighboring zone, thereby indicating the presence of permeability barriers. Pressure in the zones of injection have also been monitored using the formation tester. Such a case is shown in figure 7. In this example, 22 wells were drilled some years after water flooding was begun in a reservoir. Formation tester pressure data from these 22 wells were used to plot a counter map of the formation pressure. This map clearly shows high pressure risks associated with the banks of injection well and true associated with the producing wells.
Good afternoon, my name is Ahmad and I'm going to explain the formation permeability part. Okay, first of all, we said previously from the part of TAF and from the part of AIMAN that we can use formation wireline test to determine many things, and one of those things is the permeability. Here we have two major categories. The first category is the pre-test, and the second category is the sample test. And below those categories we have like some subdivisions, but we are going to discuss this later in details. Okay, but first of all we have to know what is the mechanism of determination of the permeability. Okay, if we are going to see the curves of the pressure drawdown or the build-up tests, we will have like a significant effect of the permeability on both those curves. And from here we can record the presence of the permeability effect on those curves, and from it we can get the permeability values. Okay, or like an overview of the permeability throughout the formation. Okay, generally those two major methods, the pre-test and the sample test, we can divide them in like four major categories. Okay, first of all, as we see in figure number 1, we can see here like we conducted a normal drawdown test. Of course, we produce at constant flow rate, and we are going to record our time response of pressure at each time, T1 and T2. And after we shut in the well, we actually will get our permeability, the best response for permeability, and actually it will be an indication of our formation permeability. Neither this delta B1 or delta B2, it will be this delta B after the shut-in. Okay, this is the first one. And the second one, as we see in figure number 2, here we actually have like something interesting. We get our values of the permeability, actually the relative permeability from the low. K effective is equal to K absolute multiplied by K relative. So we'll get our relative permeabilities nearly for oil and water, and then we will use both of them to draw this relative permeability curve or graph. And actually once we get our saturation of irreducible water, we will draw a line vertically up to cut the curve of relative permeability of the wetting phase, which is here is water, is oil. And at this point we will get our value of K relative of the formation, and it was like measured and recorded that it's nearly less than the half of the permeability of the wetting phase. Okay, we have two hints here. The first one, the relation shape for both of those tests like is a function of both the shape factor, the flow rate of course, and viscosity of the fluids, and of course the delta B of the drawdown. The second hint is the limitation for using this one. First one, if your K is very high, very high, so your drawdown delta B will be low and you can accurately calculate your K. The second case, if K very low, you will be dropped below the bubble point pressure, and what will happen then? Some of the portion of gas or vapor, infiltrated water will evaporate, and so your volume calculated by the recording of piston of this test will be much lower than the withdrawal of liquid actually happen in the field, and this is not good for your calculations. Okay, you will have some deviation. And the third case, if you are producing from a small production zone, your H is small, so your K is not the cable formation, it will cable for the skin zone or the damaged zone, and so it's not an effective indicator for your permeability. Okay, the third test is large sample fill-up time. Okay, first of all about this test, we previously said we have pre-test and sample test. For sample test, you will use a chamber, you fill this chamber, and then you will record the time. This time will be indicator of your permeability. Okay, you can use some graph to get the permeability versus this time, and of course your delta B will be reduced to the B of the formation. The fourth one is the sequential pressure readings versus depths. Actually, you will get your readings of depths while you are lowering your gauges inside the well, and you will get your pressure gradients plotted against the depths, and then you will get three regions: gas, oil, and water, and you will have your contacts GOC and WOC, and then you will get density, permeability, and whatever. And that's all of it. Thank you.
Fluid sampling. Based on the ability of fluid freely fill the pretest chamber, a large sample of formation fluid can be taken for analysis on the surface. The larger sample can range from 1 to 10 gallons or more. Due to mud filtrate invasion, a large fraction of the retrieved fluid may be mud filtrate. Proper analysis of the sample involves discriminating the filtrate from the native formation fluids. Measurement of water resistivity, API gravity, gas to oil ratio, and water chemistry can be performed at well site with prior planning with the vendor. Formation fluid samples can also be maintained at formation pressures and shipped to laboratories for detailed analysis. However, shipment of the pressurized samples may require use of special vessels approved by the Department of Transportation, and prior arrangement should be made with the involved vendors.
That's all the time we have to discuss on wireline formation testing. Let's recap on what have we discussed. The first thing, we know that wireline testing performed by both drawdown and build-up to acquire pressure data. Second, we have discussed on operation of tools wireline formation test. And then we talk about pressure measurement and its application in particular test. Next, we mentioned on formation permeability and how to get the formation. Lastly, we explain about fluid sampling and wireline formation test. I hope that you enjoy our video and gain some knowledge on wireline formation test. So thank you and have a nice day. Bye!